Welcome to Pomodoro Joe for Thursday, March 30th, 2023. Today we're looking at LeetCode problem 87, Scramble string. This is a hard problem. So in this problem we're given this isScramble function. It takes two strings, s1, s2. We return true if s2 is a scramble of s1, or false if it's not. Now we have to define what a scramble is. So the scramble algorithm is defined here. You split the string into two non-empty substrings at random. So you choose a random index and you split the string into two. They're calling it X and Y, I'll call it left and right. Once you split the string into two, you can optionally swap the two sides. So you can swap left with right, or you can keep them in the same order. Now that's another random step. Then you recursively apply the same algorithm to each of those sides. You run the same algorithm on the left and the right. So you split the left into two, optionally swap, and keep recursing down until you have just one character. So that is your algorithm. Let's see an example. So in the first example, they have string 1, great, string 2, RGEAT. And the answer is true. And they go through explaining how you split. So they split at GR and EAT. They don't swap. Then you split again. G splits with R and E splits with AT. And again, in this one, G and R swap, EAT does not. All right, let's look at example 2. ABCDE and CAEBD, and this is false, but they don't explain why it's false. So we don't really know why. And then our very base case, we have two single character strings, and it's true because they match. Okay, so we'll put 25 minutes on the Pomodoro timer and get started. All right, so I think this is tough. So the algorithm itself is not that complicated to follow for the scramble. So we could actually just brute force this. We could take S1, calculate all the potential scrambles, and see if any of them match S2. We could definitely do that. It's probably going to be computationally intense though, and I am guessing it won't run in the runtime we need for this problem. Okay, so what are the other options? Well, when I run into a case like this that it's sort of difficult to wrap my head around, I like to take a step back. We were looking at the specifics. Let's look at some of the generalities. So what's the general algorithm here? Well, you split the string into a left and right. I won't call them halves, a left and right component. Once you split that string into the left and right components, those groups of characters, the left group of characters and the right group of characters, you'll be scrambling those again. Those can change order within themselves, but they are no longer able to intermingle. So you've created two groups of characters that are very distinct. You've split into a left and a right. The distinct left characters will always remain together, and the right characters will always remain together. They can't intermingle with each other. They might swap the entire group order, so group right might go to the left and left might go to the right. But that only happens the one time at the very beginning. Once you're set in your side, those groups remain intact. So what I think I want to do is compare groups of characters. They don't have to be specifics in the order doesn't have to be specifically the same, but the group of character has to match. So here's my thought. So we'll go through, find every split point in string 1, check a matching split point in string 2. Now, string 2 may have swapped the two sides, so we'll have to check both the non-swapped and the swapped version of S2. Once we determine there is a match in terms of the characters, not the ordering, just the characters in that group, then we'll recurse and do the same on the left and right sides. If we find that there's no matching group, then we can return false. So that's my plan. All right, so let's get started. Now we could actually make this is Scramble our main function instead of having an internal function that I'm calling is Scramble recurse. But I have a feeling we're going to want some dynamic programming in here. So we'll start with this. I'm going to call it x1 and x2, just so they don't get confused with s1 and s2. All right, so I think the first thing I would want to do is make sure that these two have the same sets of characters, and if they don't, we'll just return false. But this is tricky. So, like, my mind says do something like this. All right, so we'll create sets out of the characters in S1 and the characters in S2, and if the two sets don't match, we'll return false. That sounds pretty good on paper, but the problem with set, in this case, I mean, sets are great, I love sets, but in this case, sets will remove any duplicates. So let's say we have all character A's in set 1 and all character B's, or no, sorry, we have like 5 character A's in S1 and 4 character A's in S2. These two sets will match because they both have A in the set. But that's not going to help us here because we want to make sure that all of the characters and their counts are the same. So we can't use set in this case. But what we can do is this is sort of a trick I've learned along the way. You can sort S1 and sort S2. So if the sorted S1 doesn't match the sorted S2, we'll return false. Now what sorted will do is it will sort in ascending order, which means that all the characters should have the same places and the same counts if these two are matching. All right, so that's our first base case. Are these two groups of characters the same or not? If they're not, we'll return false. All right, what's our next case? Let's see. I think it comes down to this case here. If we only have one character, we can't really do the split. So let's just check if the length of S1, they should always be the same length, so we don't have to check both. If the length of X1, I'm already messing this up. These should be X1 and X2. So if the length of X1 is 1, and now we'll just check to see if the two are the same. X1 is equal to X2. Then we can return true. All right. Now, if these are not the same, but the length is 1, well, we'll have caught that up here, so we don't need to do any additional checks. Now we get to the heart of the problem. We need to split these into all the different possible split points and check to see if we can find matching groups. All right, so for every index in range, now we don't go from 0 because all of our substrings have to be non-empty. So we go from 1 to the length of X1. Now this index will represent every possible split point along the way. So let's see, we have left, I'll call it left 1 for X1. And that's going to equal X1 up to index I. So this will split X1 into all the characters up to index I. And then right, so right 1 will be X1 from index I to the end. Okay, now we have to do the same thing for X2. So now we've split our X1 into all the different possible left and right substrings, and we've done the same thing with X2, but we haven't handled the swap. If X2 did the swap, we need to actually check, it's sort of the inverse left and right. So I'll call this left 3. So the way I'll do this, is I'll just take x2 and I'm going to reverse it. You can reverse the string by splitting with a step of -1. So basically, this just reverses the string. So what was the last character becomes the first character, and vice versa. And then we still need to do our same left and right split. All right. Now that we have all of these different sets of characters, remember we can just think of these as groups of characters. Let's compare them. So if we find two groups that are the same, then we can call the recurse on this is Scramble recurse function. All right, so if oh, no, this presents a problem. So we'll have to do the same thing we did up here. We'll have to do this sorted to see if these groups match. Well, instead of doing this, so we basically have to do this. So we have to check if the sorted left 1 is the same as sorted left 2, and sorted right 2, sorted right 1 is the same as sorted right 2. Then we can call recurse, passing in left 1 and right 1, left 2 and right 2. But we're already doing this comparison inside of our recurse, so what if we just recurse on these directly? So let's do that. We don't need to actually do this check, this sorted and this sorted, because once we get in here, we're already doing that same check. So we'll just call the recurse. So this will become, let's see, is Scramble recurse on left 1 and left 2. So we have left 1 and right 1. These are our base input strings split into a left and right part. Left 2, right 2, this is our scrambled string split into complementary or equivalent left and right pieces. And left 3 and right 3, that is our S2 reversed split into complementary or equivalent left and right pieces. Now we just have to say, well, let's check, is the left 1 a scramble of left 2? And is the right 1 a scramble of right 2? So if left 1 and left 2 are scrambles, and right 1 and right 2 are scrambles, then we can return true. Now if they're not, it doesn't mean we're done. We still need to check this swapped version. So we'll do the same thing for the swapped version. So now we check left 1 against left 3, and right 1 against right 3. Now if we get through to the end here, and they are not scrambles of each other, then we can return false. I think that takes care of our recursive algorithm. Now out here, we need to make our main function call to is Scramble recurse. So this will kick everything off, and we'll pass in S1 and S2. All right, let's see if this works. Something is not working. All right, let's see if we can figure this one out. And then I spent the next 10 minutes tracking down the dumbest bug ever. As you can tell from my voice, I had just woken up. This is pretty early in the morning for me, and clearly I wasn't in my full normal state of mind, because this was by far the silliest bug I've made yet on one of these videos. So, check it out. Oh, are you kidding me? Oh, Python. This return should be outside the for loop. Oh, you gotta be kidding. And there you have it. Oh, man. You've got to be kidding me. All right, I'm going to submit this because I don't have a lot of time today, but let's submit this and see if we can pass. loading, taking a long time. All right, so we run out of time. Let's use this test case. So this is a very simple function header. It has 2 strings. So a simple thing that we can do here is we can use cache. From functools, import cache. Now what cache will do, cache is a function decorator. You put @cache right before your function, and it will cache the values, the return values, for any given set of inputs. So if we have the same inputs more than once, we've already cached the value. We don't have to do the calculation again. And 1 minute left. Let's see if we can pass. So that still works. Come on, cache. Oh, and with 1 minute to go, we pass. And we get 71% for runtime and 43% for memory. Not too bad. So here's your algorithm. That's all the time I have. Maybe you can improve on this. I'm sure there's a way you can. So, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.